Bismillahirrahmanirrahim. Assalamu alaikum, dear student. My name is Dr. Muhammad Adnan Asghar, and today the topic of our discussion is how to find symmetry elements in different molecules under the subject of symmetry and magnetochemistry. It is actually the continuation of the last lecture in which we studied how to find different symmetry elements and operation in different molecules. I have assigned a problem to you people to find out the exact answer of this question. So I do believe many of you can solve this type of problems in near future. This problem was you have to state the single symmetry operation of XEF4 which has the same effect as applying a given operation several times. The diagram below shows the location of the symmetry elements concerned. We have the different symmetry elements and we have concern with these type of symmetry elements, and the location of these symmetry elements was already shown to you people. What was operation have the same effect as S4 twice, S4 thrice, S4 4 and C4 twice, C4 thrice, C4 4, sigma square and I square. So if you solve this problem, that's quite good. If you unable to solve this problem, this is not good for you and you need to learn from beginning of the lectures. So here is the solution of this problem. S4 twice is equal to C4. We know that if we apply S4 two times, we will get the same operation as performed by C2. S4 thrice is a unique one, so S4 thrice is equal to S4 3, while S4 4 is equal to identity, because if we applied S4 4 times, we will get the identity. C4 twice is equal to C4, because C4 is equal to C4. If we apply C4 two times, this operation would equal to C2 rotation. So this is the exact answer. C4 thrice is equal to C4 thrice, just like S4 thrice in B section, while C4 4 is equal to identity, just like S4 4 in C section. Sigma square is identity, I square is identity, because if we applied the same operation in two times, so we will get the identity in case of sigma, plane of symmetry and inversion center. So I would like to give some more example to find out the symmetry elements in different molecule. Here is the example of methane. It's quite easy. I think you people may be very well aware of this molecule, and I do believe you can solve this. If your answer is yes, then it's very positive thing, and if your answer is no to find out the symmetry elements in methane, then I must say you may write, because this is not as easy molecule as its look. So there are many symmetry operations possessed by methane molecule. There are about 24 set of symmetry elements and operations possessed by CH4, and here we go, there are the different symmetry operations that exist in methane. Here is identity, 8 type of C3, 3 type of C2, 6 S4 and 6 sigma D. How we can find these type of symmetry elements in methane? You better to do it by yourself, but if you are unable to find these symmetry operations in methane, I suggest you to go to the ChemTube website to look into the structure, three-dimensional structure of methane. Here we can see this is the CH4. You can see this is CH4. Actually the hydrogen on your observer side, and here we can see this is the CH4 molecule. Now I would like to show the C3 axis in CH4 molecule. Here, this is actually the C3 rotations that we can found in CH4. Here you can see this is the axis of rotation, C3 axis of rotation. Here I do believe you can understand quite easily now. These are the C3 axis of rotation in methane. Now we would like to show the C2 rotation. Yes, here it is. There were 3 C2 in CH4, and these are the axis of rotation of C2 in CH4 molecule. Now let's talk about the different sigmas that is present in CH4. Here we can see there are 6 type of sigma D is present. Here you can count the different sigmas present in CH4 molecule. So if we talk about the last one, S4 rotation, you can just click this, and here you can see the S4 rotation present in CH4, and this is the sigmas changing. I would like to show the complete set of symmetry elements in CH4, and here is the complete set of symmetry elements in CH4. You better to get a model of CH4, any tetrahedral geometry you can get, and you have to try to find out the all possible symmetry elements along with operations in methane. So the next example I would like to show is and here we can see this is actually the axis of rotation of the methane shows. So it will be quite helpful to understand the theoretical finding of the symmetry operation in CH4, and if we place this in a cube, it will be quite easy to find out the different symmetry operation in methane. So here is another example. Find out the complete set of symmetry elements in staggered ethane. There are 2 type of ethanes. One is the staggered and the other one is eclipsed. Now I would like to talk about only the staggered molecule, because it's quite tricky molecule and it's quite difficult to find the symmetry elements and operation in staggered molecule. So first of all, we need to learn the exact structure of staggered ethane. Here we can see that it would be quite helpful to understand the structure of the methane, and here is the schematic diagram of the methane, staggered methane. So here we start what we need to study. We know that there should be identity in every molecule, so we need to write E first. So there is a C3 rotation is also found in staggered ethane. Here we can see this is the axis of rotation, and I would like to show more easily in this way. Here we can see this is actually the C3 rotation in staggered ethane. If we provide C3 rotation to this molecule, the molecule should be indistinguishable and its structure is like this. And we have both of the options that we can either rotate this staggered ethane molecule clockwise or anti-clockwise. So in this example, I would like to show the anti-clockwise rotation in staggered ethane molecule. If we apply the C3 in staggered ethane molecule anti-clockwise, so what will happen? This A will come over there at the position of C, and C will join the position of HB, and HB will definitely join the position of hydrogen A. So the structure would be like this one. Here we can see this is the C3 rotation that we have provided to the staggered ethane molecule. So if we applied another C3 rotation, what will happen? Just like this one, the HA will replace the position of HC in this molecule, and HC will replace the position of HB, and HB replace the position of HA, and we will get the structure of staggered ethane like this one. So we can also set this is actually C3 two times, C3 twice. So there are two C3 exist in staggered ethane molecule. Right now we have studied the three symmetry operations in staggered ethane. One was the identity E, the second one was the C3 rotation, and third one is the C3 twice. So this is the C3 twice. Now let's move to the other symmetry operations found in staggered ethane. So this time actually this is the axis of rotation, but for our easiness the structure would be like this. I will show you the real structure in 3-dimensional afterward. So this is the C2 axis of rotation found in staggered ethane. We can see there are three different types of C2 axis of rotation exist in staggered ethane. Here you can see this is the C2, this is the C2, and this is the C2. We have shown this is C2, this C2 dash and C2 double dash. So now we will need to study the what is the effect of C2, what will be the effect of C2 dash and C2 double dash on the operation of staggered ethane. So the first is the C2. If we apply the C2, what will happen? You can see this is actually there are two types of bonding that is actually showing, the solid one and the dotted one. Solid one means towards the observer and the dotted one is away from the observer or the outside of the other plane. So in this you can see this is actually if we apply the C2 of this side, you can say this is actually the C2, or you can take it either this side or the other side. There will be no effect on that kind of rotation. So HF will take the place of HA. Here you can see HF will take the position of HA, and HA subsequently take the position of HF. Meanwhile HE will replace the HB, and HB subsequently HE. Here you can see that, and same side HC will replace the HD, and HD replace the HC. This is actually the C2 rotation in staggered ethane at this axis of rotation. So if we applied the C2 dash, C2 dash is here, we can see C2 dash is here. So what will happen? HD, HE and HF that was on the dotted line and that was on the back side of the molecule, on the other side of the molecule, will appear upward and change their positions. So this is the C2 rotation. You can see what kind of changes have been done while applying the C2 axis of rotation on staggered ethane molecule. That would be quite easy to understand. And what about the C2 double dash? This is actually the C2 double dash. This will also happen to the staggered ethane in the same manner as did by the C2 dash. So the molecule on the front side will go on the back side and the back side on the front side, and the position of the atoms have already changed. So this is actually the finding of C2 axis of rotation in staggered ethane molecule. So far we have studied 6 symmetry operation in staggered ethane. First one was the identity, second one was the C3, third one was the C3 twice, fourth one is the C2, fifth one is C2 dash, and the sixth one is C2 double dash. So here we go. Now let's move to the sigma D. We know that there are 3 types of sigma D present in this molecule. Here we can see, for our easiness, we have drawn the molecule like this, and there are 3 sigma D, one from here, another from here, and the other sigma D dash, and sigma D double dash, labeled as different sigma D's present in the staggered ethane. So what will be the effect of sigma D on this staggered molecule? So if we talk about the sigma d along this axis, HA and HF will never change. Here you can see that. But the position of HD and HB, HC and HB will change. HD will go to the HE side and HC will occupy the position of HD, because we are applying plane of symmetry at this axis. So this molecule will go over there and this molecule will have impact on the other side. Same is the case with the HC and HB. So here we can see that this is actually the operation of sigma d that is done to the staggered ethane molecule. Let's talk about the other sigma dash. So here we can see this is actually the sigma dash. If we talk about the sigma dash, it is actually this plane of axis, this plane of symmetry. So HD and HB will never change, they will look like similar. Here you can see that HD and HB do not change their position, because this is actually the position of the plane of symmetry and sigma. But the change will occur to this side. If we apply the sigma over there, HA will show its shadow over there, while the HC will show its effect on the position of HA. Same is the case with HF and HE. They will shift their positions, and here we can see this is actually what happened to the after applying sigma d dash to the staggered ethane molecule. The third sigma is the sigma d double dash. Actually this is the axis plane of symmetry of this sigma d double dash. So what will happen when we apply sigma d double dash to the staggered ethane? We can see that there would be no effect on the HE and HC after applying the sigma d. So what happened? If we applied the sigma d double dash, that would be the HE and HC position that would not going to be changed. The changed position should be the HA and HB, because this one have effect over each other and they will show different shadows over there. So they will change their position. HA will replace the HB and HB, subsequently HA. This is the same case with HD and HF. So we have sigma d double dash over there, and this is actually the exploration of 3 sigma d in staggered ethane. So far we have studied 9 symmetry operations in staggered ethane. One was the identity, the second one was the C3, the third one was the C3 twice, fourth one was the C2, fifth one was the C2 dash, sixth one was the C2 double dash, while the seventh one was the sigma dash, sigma d, and the eighth one was sigma d dash, and the last one sigma d double dash. But there are other symmetry operations also present in staggered ethane. Let us find how many it have. So this is all about the identity. This is all about the inversion center. Now we need to talk about the inversion center in staggered ethane molecule, whether it contains or not. And we know that staggered identity means inversion center mean we need to draw a center point in a molecule, and we need to travel on both of the directions opposite to this point. If we found the same atom on both sides, it means that molecule possesses inversion center. If not, then there is no inversion center. Ethane also has an inversion center that lies at the midpoint of carbon-carbon bond. Here we can see this is the carbon-carbon bond, the center of the molecule. Actually, every time for the inversion center we need to find the center of the molecule, and actually this is the midpoint of the staggered ethane, and there is another addition of symmetry operation in staggered ethane. So far we have 10 symmetry operations found in the staggered ethane. So let's talk about the improper rotation, and we know that the improper rotation is actually the two operations. First is the rotation followed by reflection. So followed by reflection is the actually the improper rotation. So there is S6. S6 means we need to apply the C6 first. C6 means 360 over 6. So 60 degree, we need to rotate the 60 degree molecule. Here we can see that if we rotate the molecule 60 degree anti-clockwise, what will happen? This HA will go exactly to the HD place, and HD will shift the HC, and HC will take the position of HF, and HF will take the position of HB, and HB will take the position of HE, and H will subsequently take the position of HA. This is C6 rotation in staggered ethane. C6 rotation means we need to rotate this molecule 60 degree anti-clockwise. You can even rotate this molecule clockwise, but here we are talking about the anti-clockwise rotation. So after anti-clockwise C6 rotation, we need to apply the sigma. If we apply the sigma, then what will happen? The molecule on the upper side will go to the lower, and the lower one to the upper side. Here we can see this is actually the representation of position through dotted and the solid bond, and you people are very well aware of this kind of bonding in organic chemistry and inorganic chemistry. So this is actually the addition of another S6 in this molecule. But this molecule also have S65, and if we talk about the S6 twice, if we applied the S6 twice, this is actually the C3 rotation. So there is the repetition of the symmetry operation that we found already in this molecule. If this will occur, we do not need to write the symmetry operations because it will coincide with the major symmetry element, that is C3. So we do not need to write C6 twice, we need to write the C3 as we have already written over there. So here is the complete description of the here is the actually before complete description of the staggered ethane molecule, there are some operations, S6 operation, which is equivalent operation to the other symmetry element. For example, S6 have no clash with the other symmetry operations or element, but S6 twice have, as I already told you, it have clash with the C3. So C3 we need to write the major symmetry element instead of this operation. This is actually the C6 twice is the operation of improper rotation. C6 thrice is equal to the identity, so inversion center would, so we do not need to write the C6 thrice. C64 is actually the C3 twice that we have already seen here C3 twice in the first, here we can see. So we do not need to write the C64. C65 is the unique one, so we need to write in the symmetry operations, while C6 is actually the identity, so there is no need to write the C6 because we have already written the identity in the symmetry operations. From this staggered ethane molecule, I would like to show the three-dimensional structure of the ethane molecule. That would be quite helpful to study the effect on the different symmetry operation on the staggered ethane. So this is the molecule of staggered ethane. You can see here we can go. This is the staggered ethane molecule. I would like to give you the clear picture of staggered ethane. Yes, this is actually what we have shown you in the different slides. This is actually exactly the same structure. You can see there are three hydrogen atoms towards observer, towards you, while the rest of the three hydrogen atom is away from the observer. So this is actually The away was shown as a dotted line, while towards you was shown as a solid line. So there are different operations and symmetry elements present in staggered ethane, and I would like to show one by one to you. Show the axis. So axis of rotation, it need to know. This is actually C3 rotation, and this is the axis of C3 rotation in this molecule, staggered molecule, and this is the same axis of rotation of C3 twice. So this is the same C3 axis of rotation for C3 twice also. So we know that there were 3 C2 present in staggered ethane. These are the axis of rotation of C2 rotations. You can see it's quite obvious and clear from this three-dimensional diagram of staggered ethane. Yes, you need to learn how to find the different symmetry operation in this molecule. So now what about the sigma d? Yes, there were 3 sigma d, as you remember. I would like to show all the 3. This is the first one, the arrow is where the arrow is still. This is the first one, and this is the second one, and this is the third one. You can see these are the all 3 sigma d present in the staggered ethane. Here you can see this is the all the sigma d present in staggered ethane. And here is the complete description of symmetry operations found in the staggered ethane molecule, which would be identity, rotation 5s, 2c3 and 3c2, while reflections were 3 sigma d, inversion was 1, and the improper rotation was 2, 6 s6 and s6 5. So there will be total 12 symmetry operations found in staggered ethane molecule. Now let's talk about the other molecule example. For example, this is the SF6. Find out the complete set of symmetry elements in SF6 molecule. So here are the different views of SF6 molecule. You can see there, this is the view down 4 axis, oblique view, and view down 3 axis. So from these 3 axes we can easily understand the exact structure of SF6, and we know that SF6 is actually the octahedral geometry, and there is actually the 4 ligands attached in this fashion that we can draw a simple square planar geometry, while the 2 pyramid have joint with the other molecules, and it will exhibit the structure of octahedral. So could you draw the different symmetry elements and operations found in SF6? Yes, you can have at least a good try to find out the possible symmetry elements and operation in SF6. But for your kind knowledge, I would like to tell that there are about 48 symmetry elements and operations found in SF6, including identity, including 8c3, 6c2, 6c4, 3c2, inversion center, 6s4, 8s6, 3 sigma h, and 6 sigma d. These are all symmetry elements and operations found in the SF6 molecule. So there are about 48. We need to find them very comprehensive way. This is actually the all the 4 symmetry elements found in the SF6 molecule. So from now on, I would like to show the 3D structure of this SF6, because from these positions it is quite difficult to find out all the symmetry elements and operation in this molecule, because we are unable to understand to find out all the complete set of symmetry elements through these diagrams. So let's have a look on the three-dimensional structure of SF6. Here is the SF6 molecule. You can see this is the SF6. Yes, octahedral geometry, and there are many symmetry elements present in SF6 molecule. So let's talk about the C4 rotation. We know that it's quite easy to find out the C4 rotation. This is actually the position and axis of rotation in SF6. Here you can see this is actually the principal axis of rotation, because there is not a big number other than 4. So this is the C4 rotation you can find there, and there are different C3 and as well as C2 rotation are also in this molecule. Where are the C3 axes? From this you can see these are the different C3 axes. Here you can see these are the different C3 axes axis of rotation, from where you can find the C3 in this SF6 molecule. There are so many, 8 C3 axes. And what about the C2? Yes, here you can see this is the C2 axis of rotation in SF6. There are so many C2, almost 6 C2 is present in SF6. So let's move to the planes, show planes. These are the planes showing in SF6 molecule. I have already told you there are 3 sigma H and 6 sigma D. There are 9 plane of symmetry operations present in SF6 molecule. This is quite complex molecule, and there are so many symmetry elements present and operations present in this SF6 molecule. Now show all the symmetry elements. This is all the symmetry elements present in SF6. So you are advised to study from the three-dimensional diagrams, three-dimensional structure of different molecules to complete for the complete finding of symmetry operation in this molecule. So you better to remember this website chemtube3d.com. This is quite useful to find out the complete set of symmetry elements as well as complete set of symmetry operations present in three-dimensional molecules. This was all about the SF6 molecule, and this is the complete set of symmetry operations found in SF6 molecule. You better to try by yourself and to try to get as many operations as you can find. So thank you very much. This is all about this lecture.